Hello and welcome to first edition. From today, we are starting the series of videos on basics of electronics. In this series, we will be going through various topics like basics of semiconductors, different transistors, diodes, their characteristics, different amplifiers, oscillators, op amps, and obviously the topics you all will search. To watch the complete video for interesting facts along with. So let's get this started. What all we will be seeing today in this topic is basics of semiconductors, resistivity, how to define resistivity, there is a resistivity chart in it, conductors, insulators, and semiconductors. These are the three kinds of material which depends on resistivity, and n-type semiconductor and p-type semiconductors. Moving on to our first topic, basics of semiconductor. See, unlike the resistors, which is being one of the most passive basic component which we know in any circuit, the signal diode are the most basic active component. A diode does not behave linearly with respect to the applied voltage, as it has an exponential IV relationship and therefore cannot be described simply by using Ohm's law as we do for resistance. So here we will define diodes. What are diodes? Diodes are unidirectional semiconductor devices. By word unidirectional, what we mean is it should be in the one direction. It should be flowing in the one direction. The diodes also do the same thing. Diodes are those materials or those devices that only allow current to flow through them in one direction, acting more or less like an electric wall. Now let's see how actually a diode is made, or just a basic construction of the semiconductors or the diodes. So here we can see that diodes are made from a single piece of semiconductor material having resistivity values somewhere between insulators and conductors, with one end having a positive P region and the other end having a negative N region. Knowing these facts, but still, what is a semiconductor material? We get this. So first we'll take a look at what something either a conductor or an insulator is, so we could know what is semiconductor is, as its resistivity value is somewhere between insulators and conductor. You must be knowing about conductor and insulator first. Before moving to know what is a conductor or insulator is, let us know what is that parameter which we say resistivity, on which all three materials depends on, like conductors, semiconductors, and insulator. Let's see what it is first. So any electrical resistance of an electrical or an electronic component or a device is generally defined as being the ratio of the voltage difference across it to the current flowing through it. That is famous Ohm's law. If we take for an example the potential drop between the 2 points, it's actually the potential difference between the 2 points of a circuit divided by the current flowing through it. That way we describe resistance. And the quantity that is used to indicate this resistance is called resistivity. on what our materials depends on. And it is symbolized as rho. It is a Greek symbol. It is measured in ohm meter. Ohm meter. Hope you all know the symbol of ohm relative. It is inverse of conductivity. But there is some issue with taking resistance as a parameter to measure. So, what are those? As we know that resistance is equals to rho L by A. We know this formula, R is equals to rho L by A, which implies resistance is directly proportional to length and inversely proportional to area. So, taking an example, if we increase the diameter or size of its resistance value, would also increase. And if we were to increase the length of the material, its resistance would also increase proportionally. Suppose we are taking any resistance of length around 2 meter or 1 meter, any meter of length, and we are exceeding by some x, then its resistance value will also increase proportionally as resistance is proportional to its length. On contrary, if we are increasing the diameter or size, its resistance value would decrease. Okay. Now here is a resistivity chart. What this chart indicates is that the resistivity value between the silver and the copper is very less. See, 1.60 into 10 to the power minus 8 to 1.6 10 to the power minus 8. On the other hand, on contrary, the resistivity value of glass and hard rubber, they vary a lot. From 10 to the power 13 to 10 to the power 16 to 10 to the power 10 to 10 to the power 14, this vary a lot. This difference in resistivity, the difference in this resistivity value between part is due to the impact in their ambient temperature. As metals are much better conductors of heat than are insulators. Now, after getting to know about what resistance and what resistivity is and at what parameter we should be measuring resistivity, that is ohm meter, we will come to know about our materials like conductors, insulators, and semiconductors. So first of all, we'll see the conductor, what it is all about. So from our discussion, we get to know that conductors allows flow of current, and they allow flow of current because they have a lot of free electron moving in their outermost orbit shell. The low value of the resistivity of the conductors allows them to easily pass an electrical current due to there being plenty of free electrons, as I mentioned earlier. But these electrons will only flow through a conductor if there is something to spur their movement, and that is something electrical voltage. Consider free electron as the notorious child of the family. They they'll move around the family, but in a very distinct manner. And as soon as they get some spur from any one of the outsiders or any guy, they move randomly, creating a relationship with another orbiter or with another atom. The opposite happens with the insulators. it has a very less flow of current because it has a high resistivity value, and the free electrons are closely packed to each other more in a crystalline band, is forming a crystal-like structure. In conductor, electric field exists on the surface but remains zero inside the conductor. In insulator, electric field do not exist. In conductor, potential remains the same at all points on the conductor. In insulator, conductivity is low, and some more. Examples of conductor are all metals like copper, aluminum, and many more. In insulator, all those materials which restrict the flow of current, like non-metals, marbles, ceramics, wood, anything. Now moving on to our next slide, we'll see an interesting case of carbon. Carbon being a non-metal also, they conduct electricity. Do you know how? If you know, please mention in the comment section below and let us know, or watch the complete video to know the answer. Till then, we'll move on to our next topic, and that is semiconductors. Now, semiconductors, the most important topic today is semiconductors, basics of semiconductors. So semiconductors are materials having their electrical properties in between conductors and insulators, as we know in the earlier slides. The materials such as silicon, germanium, and gallium arsenide are some intrinsic material. Intrinsic means these are pure material consisting of only semiconductor property and nothing. These are not very good conductors, not they are very good insulators. They have very few electrons in their outermost shell, as their atoms are closely grouped together in a crystalline pattern called crystal lattice. The ability to conduct electricity can be increased by replacing or adding certain donor or acceptor atoms. So, when we talk about replacing or adding certain donor or atom, there's a method in that is doping. Doping is the method by which we add or replace the atoms from the elements. Either we add certain donor atoms or we replace. But silicon being the most intrinsic conductor, that is, they are chemical pure, as I mentioned, containing nothing but semiconductors material. But by controlling amount of impurities added to this intrinsic semiconductor material, it is possible to control its conductivity. The process by which we do is obviously doping. The next we'll see is how the N-type semiconductors are formed and it's so N-type semiconductors. When we introduce a pentavalent atom, what is a pentavalent atom? Pentavalent atoms are those elements having 5 atoms in their outermost orbitals, outermost shell. These are generally from 5th group of the periodic table. that is arsenic, antimony, bismuth, etc. phosphorus. They have five atoms, five outer electrons in their outermost atom to share neighboring. So what happens? What happens here is, we'll see with an example. Like we are doping silicon with phosphorus. Okay. So what happens here? The one electron, phosphorus having five electrons in the outermost shell, in which the one electron is being left. This one is being left. The other four electrons make the bond with the silicon electron that are moving outside the outermost. So what this free electron will do? Due to this free electron, there is a process. Due to that free electron, there is a flow. They allow 4 out of 5 electrons to bond with the neighboring atom, leaving one free electron to become mobile. That's what is happening here. These are known as donors, as each impurity atom donates one electron. And due to the flow of that one electron, there is a flow of electricity is possible. And so this semiconductor starts to conduct electricity, not as like conductors, but yes, a bit. The resulting semiconductor material has an excess of current carrying electron, each with a negative charge, and is called. As this electron has a negative charge on it, and when they start flowing, they carry negative charge in majority. So this becomes an N-type semiconductor. Electrons are majority carriers and holes are minority. Holes are those which is a positive charge. Okay. Now we'll see a P-type semiconductor. What a P-type semiconductor? P-type semiconductor, we are adding trivalent impurity. What is a trivalent impurity then? Likewise, we have studied in pentavalent. Pentavalent has 5 electrons outside in the outermost shell. Trivalent has 3 atoms at the outside of the shell. Atoms having 3 electrons in the outermost orbital. Due to this, the bond can be made and having an abundance of positive charge carrier known as hole where electron is missing. What we mean about this statement is, see here, when we are doping silicon with bismuth, okay, bismuth having 3 electrons in the outermost shell and silicon having 4 electrons in the outermost shell. So here see the 3 electrons are getting paired with the atoms, the other electrons of silicon, but here this one, it remains vacant. It remains vacant, and so this silicon atom from here, one electron will move from here to here, creating another hole here. Okay. So there will be always a void be created, as the other electrons will keep on moving to fill up the other place. Similarly, from here, hopeful, the next electron will come here and make the complete bond here. Further on, we can see the other picture also. So that's what we mean here. Adding trivalent impurity into the crystalline structure, that is atom having 3 electrons in outermost orbital. Due to this, the bond can't be made, and giving an abundance of positively charged carrier known as hole where electron is missing. As there's a hole in silicon crystal, it is positively charged. I told you that Holes are positively charged positively charged. An electron from neighboring atom will be attracted to fill that hole. In this process, an electron leaving the place creates another void at that place and resulting to the flow of electrons. This movement of holes result in shortage of electron as there will always a void created and the electron will keep on moving and coming to the place. The entire lot is a positive pole. So this is a p-type semiconductor. These are accepted as impurity atoms generates a hole. Hopefully you are till now you have been cleared about n-type and p-type semiconductor. If you are not, let us know in the comment section below. Moving ahead, we'll see a summary of n-type and p-type. Fifth group element is added as a doping element. And p-type, third group element is added as a doping element. Impurity added provide extra electron. Impurity added creates a hole. Pentavalent atoms like arsenic, antimony, bismuth, etc. Trivalent atoms like aluminum, gallium, indium, etc. Electrons are majority carriers, holes are majority carriers. Now, if you all remember about our carbon topic, what was about carbon, how they are conducting. Okay, so as these materials have very few electrons in their outer valence shell, resulting them easily knocked out of atom's orbit. Okay, this allows them to flow freely through materials until they join up another atom, producing a domino effect through the material, thereby creating electric current. So this will remain for today. I will wind up here. And a task for you all, let us know about what is a domino effect in the comment section. And if you like the video, please share and subscribe to our channel. Thank you. Till the next time.
That's all for this video. See you in our next video. If you liked our video, please do like, share and subscribe.